Hey guys, today we're going to talk about understanding the hyperbola. So, looking at the equation and pulling out key information or identifying features, and then using those identifying features to graph the hyperbola. Down here, we have our general form of a hyperbola. So, that's ax squared plus by squared plus cx plus dy plus e equals 0. This is our standard form, and it's similar to the standard form of an ellipse. The only difference being that rather than being a plus sign between these two terms, there's a minus sign instead. Now, also with the ellipse, the a squared was always the bigger number and told you whether or not the equation was an x type or a y type. With the hyperbola, the leading term is going to tell you if it's an x type or a y type. So if you have x squared minus y squared, it's going to be an x-type hyperbola that opens up in this fashion. And then if it's y squared minus x squared, you're going to be opened up and down like this. So that's going to be the y-type. Similar to the ellipse, the parabola, all of that, hk is still the center. And then these a and b values are going to help us find the C value, and a whole bunch of other important information. So here we go. We're going to take some notes on finding these key features. First off, I'm just going to fill in the general forms for the horizontal and the vertical hyperbolas. So for our horizontal hyperbola, it's going to be x minus h squared over a squared minus y minus k squared over b squared equal to 1. For the vertical transversal, we're going to start with y squared. So it's going to be y minus k squared over a squared minus x minus h squared over b squared equal to 1. In both of these instances, I find the center in the same way, and that center is hk. For the vertices are going to come from counting units or counting boxes using that a distance. So if I look at a horizontal parabola, if I start at the center and go a units to the right and a units to the left, that's going to give me the equation of my vertices. So my vertices are going to be h plus or minus a, comma k. For a vertical hyperbola, I need to go a units up and a units down from the center in order to get to my vertices. So the vertices of this hyperbola are going to be h, comma, k plus or minus a. The co-vertices I find by counting boxes from the center using the b value. So my co-vertices in a horizontal hyperbola are going to be b units up and b units down from the center. So that's going to be h, comma, k plus or minus b. For the co-vertices in a vertical hyperbola, I go b units to the right and b units to the left of the center. So that's going to be h plus or minus b, comma, k. My focal distance c is going to be c squared equals a squared plus b squared. And I can find that the same way for both types. My foci coordinates are always going to be c units away from the center, and then the direction depends on which type of hyperbola we're looking at. So for a horizontal hyperbola, we're going to be c units to the right and the left. So that means my foci coordinates are going to be h plus or minus c, comma, k. And for a vertical hyperbola, I'm going to be c units up and c units down from the center. So that's going to be h, comma, k plus or minus c. The length of the transverse axis in a horizontal parabola goes horizontally, and in the vertical parabola goes vertically. So in both instances, that transverse axis is 2a. The conjugate axis is going to go vertically for the horizontal and horizontally for the vertical. So now we're backwards. And this one's just going to be 2b for both. The equations of the asymptotes, you can see they're filled in this diagram right down here. So for my horizontal hyperbola, the equation of the asymptotes are plus or minus b over a times x. And for the vertical hyperbola, it's plus or minus a over b times x. The focal chord length is the same equation that we used for the ellipse. So that's 2b squared over a. And it's the same for both. The eccentricity is also the same as an ellipse. That's c over a. The domain and the range. So in my horizontal hyperbola, the domain is my x values. So from negative infinity to negative a is going to be the domain, as well as a to positive infinity. So I just can't include anything between negative a and a. I also have to take into account if the center wasn't 0. So this point is actually the point of the vertices. So I need that x value, this h plus or minus a. So my domain is going to be negative infinity to h minus a and h plus a to infinity. The range I can see is just going to be from negative infinity to infinity. I'll hit every y value on that graph. For the domain and the range of the vertical hyperbola, for the domain, that's my x values. This thing is going to stretch all the way across and touch every x value. So my domain is going to be negative infinity to infinity. And then the range is going to be similar to the domain of the horizontal hyperbola. So for the range here, I can see that I'm going to be from negative infinity to this vertex, and then from this vertex to positive infinity. So I'm looking at the y coordinate of this vertex. So I'm going to be from negative infinity to k minus a, and then k plus a to positive infinity. Now that we've talked about all of these key features, let's do some examples where we pull these key features from an equation. Example 1 says write the equation of the hyperbola in the following graphs. So the first thing that I'm going to identify is the center, which is right here where these two lines are crossing. The center of this hyperbola is 0, 1, so that means h and k are 0 and 1 respectively. Since this equation is opening up to the left and to the right, I know that this is going to have the form x minus h squared over a squared minus y minus k squared over b squared. A is going to be the distance left and right. So if I count boxes, it's just 5 units. So A is 5. B is going to be the distance up and down from the center. And I can see if I count boxes here that that's 4 and 4. So B is going to be 4. Now that I have h, k, a, and b, I can just plug those into the equation of my hyperbola. So I have x minus 0 squared. So I'm just going to leave that as x squared. A squared is 25 minus y minus k. So that's y minus 1 squared over b squared is 16 equal to 1. Number 2. This hyperbola is opening up and down, so I know that this is going to be a y type. So I'm going to have to fill in y minus k squared over a squared minus x minus h squared over b squared equal to 1. I can see that the center of this hyperbola is 0, 2. And since this hyperbola is opening up and down, my a value is going to be how many ever units up and how many ever units down that it takes to get to each of these vertices. So my a value in this case is 2. For b, I'm counting units to the right and to the left of the center. And the b value here is 5. Now I can use these values to plug into my equation. So I'm going to have y minus 2 squared over 4 minus x squared over 25 equal to 1. Number 2, consider the hyperbola y squared over 36 minus x squared over 49 is equal to 1. So we're going to identify all of these key features, and then we're going to figure out which of those key features are going to be most helpful in graphing this hyperbola. Since this is leading with a y squared, I know that this hyperbola is going to be a y type, which means that it's going to open up and down. I know that since there's not anything being subtracted or adding with the numerators, that my center is just 0, 0. I'm also going to figure out my a and my b values. So I know that a squared is equal to 36, which means a is 6. And I know that b squared is equal to 7, which means that b is 7. Since this hyperbola is opening up and down, my vertices are going to be a units above and below the center. So that's going to be 0, 6 and 0, negative 6. My co-vertices are going to be b units to the left and the right of the center. So negative 7, 0 and 7, 0. The length of the transverse axis is 2a. 6 times 2 is 12. The length of the conjugate axis is 2b, and 7 times 2 is 14. The equation of the asymptotes, since this is a y-type, the equation of the asymptotes are plus or minus a over b times x. So the equation of my asymptotes are plus or minus 6 over 7x. So I have two asymptotes, y equals positive 6 over 7x and y equals negative 6 over 7x. For the coordinates of the foci, I need to figure out what the c value is. And I know that c squared is equal to a squared plus b squared. So I get c squared is 36 plus 49. So c squared is 85, which means that c is the square root of 85. My foci, since this is a y-type, are c units above and below the center. So my foci are going to be 0, positive rad 85, and 0, negative rad 85. The focal chord length is 2b squared over a. So in this case, that's 2 times 49 over 6, which reduces to 49 over 3. My eccentricity is c over a. So that's rad 85 over 6. And now for the domain and range. In a y-type, the domain is negative infinity to infinity. I'm going to hit every x value as this thing opens up and then opens down. The only thing that I'm going to have to exclude is y values between these two vertices here. So this is going to help me figure out my range. My range is going to be negative infinity to negative 6. And then I can't include anything between negative 6 and 6 because my hyperbola jumps from this piece to this piece. So then my range picks up again. Those y values start up again at positive 6 and will reach up to positive infinity. Now that I have all this information, let's figure out which of this information is going to be the most helpful in actually graphing this thing. I'm going to want to graph the center. So my center is 0, 0. I'm going to need to graph the vertices. My vertices are 0, 6 and 0, negative 6. I'm also going to graph the co-vertices of negative 7, 0 and 7, 0. Now, from here, I'm pretty much done. I'm going to create a box using these vertices, and that's going to help give me a guide as to where I need to plot this hyperbola. Now, since this hyperbola is going to open up and down, I know that this vertice and this vertice are points on my hyperbola. I know that this hyperbola is going to curve up here and then down here. Those asymptotes are what's going to tell me how they curve and where they need to kind of hug or what line they need to be asymptotic to. So rather than counting boxes to now graph these asymptotes, I can just draw a line through the center and through each of the corners of this rectangle, and that will give me those asymptotes that I'm looking for. So I'm going to sketch those in with a solid line. Just keep in mind, normally we would be graphing asymptotes as dotted lines. It's just easier for me with the tool that I'm using to graph them in solid lines. So now I know that my hyperbola is going to go through this vertice and hug this asymptote over here, and then start at this vertice and hug this asymptote over here, and then same thing in the bottom. So although we pulled out all of this extra information because that's what this question asked me to find, the only key features that I needed to graph this hyperbola were the center, the vertices, and the co-vertices. Let's do one more example. Number 3, consider the hyperbola 25y squared minus 9x squared minus 100y minus 72x minus 269 equals 0. For part A, I need to write the equation in standard form. I need this equation in standard form if I want to graph it and if I want to answer all of these questions below. The way that I'm going to write this thing in standard form is the same way that I did with the ellipse. So I'm going to group my y terms, group my x terms, move the constant over to the other side of the equal sign, and then we'll go from there. My next step is to factor out a GCF of the y terms and of the x terms, not including the variable, just using the coefficient. So I'm going to factor out a 25 for the y's, and I'm going to factor out a 9 for the x's. Now I'm going to complete the square for the y values and for the x values. So in order to figure out what term I need to complete the square, I half and square the b value. So 4 divided by 2 is 2, and 2 squared is 4. And then for the x terms, 8 divided by 2 is 4, squared is 16. Now over here, I have to add whatever I added on this side. So 25 times 4 is 100, so I added 100. And then 9 times 16 is 144. So it's 100 minus 144. So I really subtracted 44 on this side. So now this becomes a minus 44. Now I'm going to write this as something squared and write this as something squared. So I have 25 y minus 2 squared minus 9 times x minus 4 squared equals 225. The last thing I need to do is to get this to be equal to 1. So I have to divide the entire equation by 225. So 25 divided by 225 is going to reduce to 1 over 9. So I have y minus 2 squared over 9. 9 over 225 is going to reduce to 1 over 25. So I have x minus 4 squared over 25 equal to 1. Now that this thing is standard form, all this information will be a lot easier to pull out. So the coordinates of the center come from h and k, so that's going to be positive 4 and positive 2. The coordinates of the vertices come from a and b. So I know from the standard form that a squared is equal to 9, so a is equal to 3. And b squared is equal to 25, so b is equal to 5. The vertices are going to be a units away from the center, and since this is a y type, because the leading term is a y squared term, that this thing is opening up and down. So I'm going to write that over here. This is a y type, and it's going to open up and down, which means my vertices are a units above and below the center. So I'm going to leave the 4, and I have to add a to 2. So 2 plus 3 is 5, and subtract a from 2. So 2 minus 3 is negative 1. For the co-vertices, I have to go b units to the left and right of the center. So the y value is going to stay the same, and my x value is changing. So I have to do 4 minus the b value. So 4 minus 5 is negative 1. And 4 plus the b value. So 4 plus 5 is 9. The equation of the asymptotes. So the equation of the asymptotes are plus or minus a over b times x for a y type. So in this case, I have plus or minus 3 over 5 x. The coordinates of the foci are c units above and below the center, since this is a y type. So I need to figure out what c is. I know that c squared is equal to a squared plus b squared. So that means c squared is 9 plus 25. So c is going to be equal to the square root of 34. For the foci, again, I'm going to be c units above and below the center. So my x coordinate for the center stays the same, and then I have to add c to that y coordinate. That's one foci. And subtract that c value from the y value to get the other foci. And just leave it like this in radical form. You're not going to write it as a decimal or anything like that. The domain for a y-type equation is negative infinity to infinity. As this thing opens up, I hit every x value to the left and to the right. My range is just going to exclude those y values between the two vertices. So my range is going to be negative infinity to negative 1. And 5 to positive infinity. The last thing I need to do is graph the hyperbola. I'm going to start by graphing the center. Next, I'm going to graph the vertices, and then I'm going to graph the co-vertices. From here, I'm going to draw a box connecting the vertices and the co-vertices. I'm going to connect it with a solid line, but you should do it with a dotted line. The last thing I'm going to do is draw my asymptotes through each corner and the center of the rectangle. And again, on your page, you want the lines for this box and for the asymptotes to be dotted lines. I just don't have a dotted line feature in what I'm using to write this all out. So now from here, since this is a Y type, I know that my vertices are points on the hyperbola. This hyperbola is opening up and down and is hugging these two asymptotes. That's it for graphing hyperbolas and identifying key features. If you have any questions, feel free to leave them in the comments below. Have a great day.